Electromagnetic or magnetic induction is the production of an electromotive force across an electrical conductor in a changing magnetic field. Michael Faraday, an English scientist, is generally credited with the discovery of induction in 1831. Faraday's law of induction is a basic law of electromagnetism, predicting how the magnetic field will interact with an electric circuit to produce an electromotive force, a phenomenon known as electromagnetic induction. James Clerk Maxwell mathematically described it as Faraday's law of induction. The unification of electricity and magnetism was done by Maxwell in late 19th century. Until his work, electricity and magnetism were considered as two distinct phenomena and with no relationship between them. He is responsible for classical theory of electromagnetic radiation, which was the first theory to describe electricity, magnetism, and light as different manifestations of same phenomena. There are two important devices depend on electromagnetic induction: electric generators and electric transformers. Both devices play crucial roles in producing and regulating electric current we depend on in our daily lives. Electric generators use electromagnetic induction to change kinetic energy to electrical energy. The details of electric generator and transformer will be covered soon in this channel in another video. Let's discuss about construction of electromagnetic induction. A coil having some number of turns connected to the two terminals of a bulb, a bar magnet showing its magnetic field lines, a voltmeter is connected in the circuit. Now let's move on to the working of electromagnetic induction. With the help of animation, let me explain to you how the induced current can be generated and on what factors the induced current or voltage depend. Number 1. Changing magnetic field. Changing the magnetic field affects the induced current and voltage. This can be done either moving the magnetic field around the conductor or moving the conductor in the magnetic field. As long as there is a change in magnetic flux in the coil, it induces current. Change in magnetic field lines is directly proportional to the induced current. Number 2. The number of turns. The induced EMF, electromotive force, is directly proportional to the number of turns of the wire. The greater the number of turns, the greater will be the voltage. That means the number of turns affect the induced current and voltage. Now the question is that how the direction of the induced current can be determined. Here comes Lenz's law in 1834. It states that the direction of induced current in a conductor by changing magnetic field is such that the magnetic field created by induced current opposes the initial changing magnetic field. If suppose the north pole of the magnet pushed near the coil, it opposes the field and behaves as north pole, but when pulling away from the coil, it behaves as south pole. By knowing the north pole and south pole of the coil, we can easily figure out the direction of induced current by applying right-hand thumb rule. So this is how we can determine the direction of induced current in a conductor. Thank you.